Now we are going to talk about equations of circles. So this is if we were going to graph it, or we were given a graph. This is a relationship in graph paper. Now first of all, I cut and paste. I just want you to see that this is on the back of the geometry formula sheet right here. And I cut and paste the exact same one so we would get practice using it. So they give you a lot of information here. So really all you are going to do is be plugging in. That's all you're going to do, right? Maybe doing a little simplifying and potentially do some solving. What this is telling us, x and y, just like a linear equation, if we were graphing, say, the line y equals 3x minus 1, x and y are still in that equation, right? Y-intercept of -1, slope of 3. Okay, that would be something like that. So an equation of a line is going to have an x and a y in it, because that's what the equation does. It shows the relationship between all those points. So look at what a circle one looks like. There's going to be squares, okay? Definitely you're going to see that square and that square. You're going to see the x and the y. You're going to see those in your relationship. So what are the h, the k, what's all this stuff? So r, hopefully we're comfortable with that by now. That's the radius. Okay, notice there's a square on there. So if you're working backwards, you got to undo that. H and K, here they are in the picture. If I don't know what those are, look at my picture. What is that? Oh, that looks like a coordinate, like an x and y coordinate. But this is a special one because they're not using x, y, they're using HK. And it's special because this one, HK, is the center of the circle. Look, it's describing the point right here, the center. So I'm just going to write center. Okay, that's what the HK is. Okay, so what is this going to look like? We're going to be asked to either write an equation or graph or find a radius or something like that. So let's look at the easiest ones. They can give me a center and a radius and ask me for the equation. That's about as easy as it gets. So the -4 and 1, if that's my center, they're giving me the h and the k. So I'm going to use this. Okay, and the radius, look at my picture, they're giving me the radius. So they're giving me h is -4, they're giving me k is +1, and they're giving me the radius is 5. Alright, let's plug in. An equation of a circle is going to look like this. Remember, the x and the y are going to be in my answer. So what does this look like? I want to see the picture too. Okay. X. Now, notice, there's a minus here and a minus here. There's no negatives up here. So what that means is that whatever number goes here for h and k, they will always be the opposite of those, the actual coordinate. So, because this is minus h and h is -4 minus a negative, again, it's just always going to be the opposite of that. So if h is negative, this becomes +4. Okay, don't forget the square. Plus, I'm literally just writing this down, right? I'm substituting something in here, here, and here. That's what I'm doing. Okay, so y minus k. So again, k is going to be the y one. I have to change the sign. So minus y. Now what goes over here? Radius squared. They told me the radius was 5, so I can put 5 in there. Radius 5 squared. Alright, now an answer could actually look like that. Sometimes on standardized tests they'll leave it like that, 5 squared, but other times you'll see it like this, 25. So again, all the numbers I'm going to see right here, negative change to positive, positive change to negative. Okay, x goes with x, y goes with y. This becomes the square of the radius. So, one like this, you're doing the same thing, except you're going to have to find the coordinate first of that center, right? Because what two things am I plugging in to this equation? Alright, I'm plugging in h and k, which were the center, and I'm plugging in r, the radius. So those are the things I'm going to need to find. The coordinate of the center and the length of the radius. I can just count that, right? Alright, so I'm going to let you guys practice those, try those. Down here, Okay, so this time I have to graph. So this time I'm given the equation and I'm going to have to graph it. So here's the origin, alright, how do I know where to start? Well, I'm going to start with the center, and remember the center is at here and here in the parentheses, but this is minus and these are not, so I have to change the sign on both. So negative, negative, so this becomes positive 3, positive 2. Alright, let's graph my center. So 1, 2, 3, 1, 2. So your first step is always going to be to find the center. The other thing I need to graph a circle once I know where it is how big is it? Is it really small? Is it really big? Okay, how do I know how big a circle is? The length of its radius. Okay, so what is my radius? Well, oops, sorry, I went a little too far here. Maybe I moved this down here so we can see. Okay, let's look at it over here. So where do I see my radius? My radius here is right here. So where is that? Oh, well, it's 9. I don't see a square there, so what's that mean? That means that radius squared was equal to 9. So this time, I'm going backwards, I'm solving, I'm trying to find the radius, so I'm going to take the square root. That's how I'm going to find what the radius is. So the radius is going to be 3. Okay, so it's the square root of this, because this is radius squared. So 3 squared is 9. Okay, so let's go graph it. 1, 2, 3. Now, I can count horizontally and vertically. So from the center, I'm going to go 3 out in every direction, because that's the definition of a circle, right? A set of points that are equidistant from the center. Now, I can't really do that, so I'm just going to kind of estimate the best circle I can. Okay, that one's not too bad. You're going to get better with practice. Okay, so there's my circle. Alright, so again, pretty straightforward, right? I need 2 things. I need a center and I need a radius when I'm working with an equation. So I'm going to show you one more example. This one's probably about, I don't know, probably the toughest type. Number 6 here on the next page says, the endpoints of the diameter of a circle are at -2, 2, and 2, -6. So I had the endpoints of a diameter, and they want me to write the equation of the circle. This is as tough as it gets. So for an equation of a circle, I'm going to need to know what the center is, and I'm going to need to know what the radius is, and I'm not given either one. Okay, an in-between problem might be like this one. The center of a circle is here, so I have half of it, I'm already there, but it didn't give me a radius, okay? This one is actually, if you understand this one, you'll be able to go back and try that one. Okay, so I'm going to need, as always, when I see coordinates in no picture, some graph paper. So the first thing I'm going to do is see what it is I'm looking at right now. So let's use black here for my axes. Making sure I'm staying big enough here. Okay, -2, +2, and 2, 1, 2, 3, 4, 5, 6, 2, -6. So what I have here are the endpoints of my diameter. If you've forgotten what a diameter is, look at the front of your formula sheet. Oh yeah, wait, diameter is the whole distance across the circle going through the center. So my circle is going to look something like this, right? Okay. What do I really need though? I don't need all those points. I'm just doing a sketch here. I need the center. So where's the center going to be? Well, the center is going to be halfway on the diameter, and I'm looking at this and I'm feeling like pretty good about that, right? I can use a ruler. Alright, I can do some other things here to check it. I can use my diameter. Remember, radius is only half of it. So what this is the midpoint formula if you're a formula person. I'm not. If I want to check that I found the correct midpoint, I can easily just rise and run here and make sure that those two lengths are the same, right? Because basically what I'm doing when I rise and run is finding two congruent triangles, right? Two congruent right triangles, side, angle, side. So that's all I'm doing here. Rise and run. This is 2 and 1, 2, 3, 4. So here, 1, 2, 3, 4, 1, 2. Yeah, these are the same. So I correctly found my center. Alright, again, you could use a midpoint formula. I don't. I play around with my graph paper until I find the right point. So my center was at, I'm not moving left or right, so 0, and then down. Okay. Alright, I'm halfway there. Now, radius. How do I find the radius? Well, the radius is the distance from here to here, right? Or I could do the bottom half. Alright, well, how do I find distance? Oh, wait a minute, I can already see it. This, again, going back to distance, I just pointed you to this, right? In a coordinate plane, there's a distance formula if you're that person, but you can just rise and run, count your legs, and find the hypotenuse using Pythagorean theorem. So, it's annoying. This is a multi-step problem, but none of it is too hard. Remember that when you're using Pythagorean theorem, you have to put the hypotenuse goes by itself over here. When you're finding distance and on graph paper in a coordinate plane, you're always using your rise and run for A and B. So 2 squared plus 4 squared equals my, you know what, I'm going to put radius squared right here. I could put x, but what am I finding? I'm finding radius to go and plug in right here. So I can do all that math at once on my calculator since it's on the same side. So I'm going to do 2 squared plus 4 squared, and that's 20. So I have 20 equals radius squared, so I'm going to square root to find my answer. It's about 4.5. Radius is close to 4.5. Now, when you don't get a whole number for radius, it can be a little tricky. I mean, if you're somebody that likes to do decimals, you're going to get very, very close to the exact answer. But let me show you something here as we go plug into our equation. So now I'm looking back at, oops, sorry about that, at this equation. It's the opposite of h and the opposite of k. So I'm changing the signs on the center. And then here's the radius. So let me pull this down here. Alright. I'm plugging in x minus h, so x opposite here. Oh, it's just 0, so whether I do plus or minus, it doesn't matter. And then plus y parentheses, and then change the sign on my center here. So this is going to become minus, and negative becomes plus 2. Equals, and then what's my radius? So again, I can do this squared. But remember, what goes here is radius squared. Let's look back here for a second. Radius squared, before I square rooted, that's what I had. Radius squared is 20. So the exact answer here actually is 20. Now let me show you. If you either take what you just did and square it, answer squared, you will get exactly 20. If you do 4.5 squared, you're going to get something really close to 20, and you're going to pick the right answer in multiple choice, I would hope, right? Speaking of, a final answer for this would actually look more like this. There's nothing you're doing here. Whether you're adding or subtracting 0, that's just x squared. So sometimes, especially if you're working backwards from an equation, you want to think about, you know, what does it mean when there are no parentheses with your x or y? It means that the number was 0. Okay, my center was at 0, change the sign, -2. 0, -2. Okay, go try some practice.